In the previous lesson, we talked about how the if or the if-else statement can have one branch, the if statement, or two branches, the if-else statement. Sometimes you need to do more than one branch or more than two branches. You might want to choose one of several branches, or in this case, one of several actions. That's called chaining. So, for example, if I look at the value x right here, I'm deciding what value x is. If it's greater than 0, then it's positive. Otherwise, there's another branch. If it's less than 0, it's negative. Otherwise, this actually has three cases. It doesn't have one, two, it needs to have three, so we do an if, else, if, else, if. That's called chaining. You can have more than one branch. So in this case, it would be 0. There's also something called nesting. That means within an if branch or within an else branch, we can have another if else. So what happened here is we did the same exact thing, same exact output, basically the same program, slightly different logic. In this case, we're deciding if x is 0, just print out it's 0. Else, meaning if it's not 0, either it's greater than 0, in which case it's positive, or if it's not positive, we already tested 0 up here, so it must be negative, so we'd print out negative here. So again, this is called nesting because the if-elses are in one of a previous higher level if-else branches, and in chaining is just when you have an if and an else if, and you can go on forever. Else if, else if, else if, whatever you want to do, however many you need. Okay, a flag variable, sometimes that's used to make it a little bit more easy to read when you're looking at a conditional. For example, up here, right here, I'm deciding if n is even. Well, if n is even, that means if I divide by 2, I'm going to get 0 as a remainder. Remember the modulus operator, it gives you the value of the remainder after division by whatever number. So I divide a number by 2. If I get 0 as my remainder, it must be even. So what I did was I set up even flag as type Boolean. Boolean has two values, either 1 or 0, either true or false. If you're looking at in Java, it will come out to be either true or false. So in this case, if it turns out to be 0, the remainder is 0, means it's even flag will be true. So all I have to do is, if I'm doing something with an if-else up here, I wouldn't have to put n modulus 2 equals 0 up here. I could just put if even flag, and then I would say print out x is even. So as you can see, sometimes that makes it a little bit more readable when you're, or a little bit easier to understand for someone else who's maybe looking at your code. It may make it easier for debugging because you could then print out the even flag to see what happened. Just makes it a little bit easier to maintain and read code. You can also remember the exclamation point means not. So I'm saying if not even flag, well, that means inside this body of this little branch of the if statement, I'm going to be talking about if basically means if n was odd. So I'm going to execute that only if n is odd. Now, there's something called a return statement. Basically, when we've been having these methods, or even if you look at this code fragment here, and also our previous methods, we just keep going until we run out of code, until we fall off the end and we hit the last branch. If you need to return sooner than that, for example, if I wanted to return right after I decided what x was, positive, negative, or 0, I wanted to return right after that, I could put a return statement right here. I decided x is positive, print it out, and return. Otherwise, if I don't put a return statement there, it will keep going. Well, like actually, once it hit a branch, in this case, it won't continue, but it would continue after the if-else. So if you wanted to return from a method sooner than falling off the end of the code, you need a return statement. That'll make more sense when we look at a code example. Now, sometimes when you're using a method, you need to validate the input, or you may need to validate, for example, an argument in a method that you're doing. For example, if you're doing a square root method, you want to deal with positive integers. So you want to test, before you actually compute any square root, you want to test to see if it's a positive or 0 double. So if it was a negative, you'd put out an error message. So in this case, there's something called system.error. It uses an output stream specifically designed for error messages and warnings. In most cases in Java, that's also linked to the console in the same way that system.out, in the same way that output stream is linked to the console. So what we would do with system.error is, for example, in this case, I'm expecting to read in a double. So I want to make sure it's a double before I read it in, and this hasNext double function will read it in and it'll test to see if it's a double, but it'll actually, if it'll let me read it in, but the next thing it'll do is allow me to assign it to something. So what I'm going to do here is, it should actually be a dot instead of a comma. I'll fix that later. So I'm saying if the input stream does not have a double next, that's why I have that not, the exclamation point. If it doesn't have a double next, I'm going to take the next thing that's read in, which was the thing I expected to be a double, but it wasn't, so it must have been a string. Since it wasn't a numerical value, I'm going to put it in this value or this variable word that I declared as a string, and then I'm going to print out system.error.println is putting it to the error output stream. The input is not a number, and it'll append the word that I just read in. Then I return because I'm done. I do not want to continue in this function. I just want to return because I hit an error. Now let's take a quick look at some nested conditional statements. This method, first thing we do is we input the scanner because we're going to be reading some input. Remember we talked about comparing strings. When you're comparing strings, you don't use the equal comparison. You use this thing, whatever the first string is, dot equals, and the second string goes in parentheses. So when I output this, system.out.println, remember this is going to give a Boolean value, so it should give true or false. First thing we should see in our output based on this function that we're running, it should be false because apple does not equal orange. Okay, so now in this case, I have x is 17, n is 18. I'm figuring out if x is positive or negative. Actually, I guess I'm just checking if it's positive here. So this is a simple if statement, no other branches besides the if. So I check if x is greater than 0, which it should be because 17 is greater than 0, it should print out x is positive. If x was not greater than 0, it wouldn't execute this part at all. It would just continue down here. So I should see x is positive because it is. Now I'm checking if x is even. So it's either going to be even. If the remainder after division by 2 is 0, it's even. Otherwise, if the remainder after division by 2 is not 0, then it's going to be odd. So if it's even, it'll print out this, and it'll skip this part. If it's odd, it'll skip this part where it prints out even. Instead, it'll print out odd. So it does either this branch or this branch, not both. Now I have an example of chaining. Either x is positive, or it's negative, or the third case is it's 0. It's only going to execute one of those branches. It can't execute any more than one of those because it's either this, otherwise it's this, otherwise it's this. Now here's an example of a nested if-else. I have either x is 0 or it's not 0. If it is 0, I print out this and I don't execute any of this. If it's not equal to 0, I don't execute this x is 0 print statement. Instead, I execute the else branch, which has a nested if-else in it. That's where I test if x is either positive or negative, and then I'll end up down here. Okay, and the last case is an example of coming up with a flag, an even flag or a positive flag. Remember, even flag was either true or false if n after division by 2 gives you a remainder of 0. If it does give a remainder of 0 after division by 2, then it's even. So even flag would be true. If n was even, and remember n was 18, so it should be true. This case we're testing if x is positive. The positive flag, which is a Boolean, remember true or false, is a Boolean value. So if x is greater than 0, it'll give me a true. And remember, x was 17, so it should be greater than 0. It should be true. If the even flag is true, which it should be, 18 is even, it'll print out n was even when I checked. And then in this case, if it's not even, it'll print out this instead. So I actually shouldn't see this because n is not odd, n is even. So it shouldn't even print out this at all. It should check it, say, oh, this is true, not true is false. So this whole condition here will turn out to be false and it won't execute this branch. So I'm going to run this and we're going to see what's going to happen. Okay, so the first line of output here after running this is false, so that makes sense. Apple was not equal to orange, so I expected to see a false. Now I'm checking if x is positive. It'll execute this branch if x is greater than 0. Yes, it is greater than 0, so there's my x is positive output. Now I'm checking if x is even or odd. Remember, x was 17. That should be odd. It shouldn't print out this at all because I should get not a remainder of 0. I should get a remainder of 1. So I should print out x is odd. Let's see what the next thing is going to print out. Okay, I'm testing if x is positive, negative, 0. It should print out positive, which it did. And I'm doing the same thing but using a nested if-else. So I didn't print out that x was 0 because remember x was 17. So the next thing I did was jump down here, which tells me either do this or this. So it tells me if x is 0, print out positive. It is positive, so I print it out. The last thing I'm doing is using the even flag, or basically the odd flag, because if it's not even, it's odd. So I do the even flag, n divided by 2. What's the remainder if it's 0? N was even when I checked up here. So that's all the output, just as we expected. Let's take a quick look at the logarithm method that we have defined, the logarithm class, which basically checks to see what the log is of a number. And we're also going to show system.error in this example. Okay, so normally the main program the main class ends up at the bottom. Remember, when you're looking for flow of execution, you always start at main. If it happens to be at the top, just start there. So we start wherever main is. So the first thing we're going to do is we're going to print out the name of the function we're about to call. This is an example that you can use for when you're debugging. You want to print out where you are. You want to try to follow the flow of execution because what you think it is may be different than what's actually happening. So the first thing I'm going to do is print out this method name, because that's the first method I'm invoking. I'm going to print the logarithm of 2.718, and what that does is that'll jump down here. It'll print out the logarithm. Remember, double x, the x that I'm feeding it is 2.718. First thing it does is check the validity of the argument that I'm giving to the log function. If it's less than or equal to 0, I have an error. Remember, you cannot have you can't input a negative log. So what's happening here? Remember, when I take the log, this log function is actually using log to the base e, the natural log. Remember Euler's number 2.718. You learned about e in Algebra 2. So if I take the logarithm of 2.718, remember I'm asking what's the exponent to the base e that will give me 2.718. The answer should be approximately 1. It's not going to be exactly 1 because this isn't exactly e. Remember, e goes on forever just like pi goes on forever. They're both irrational. Okay, so what it should do is it first check it to see if it's a valid input, which it is because it's positive. 2.718 is positive. It'll take the log, it'll print out the log, and I should get something approximately equal to 1. Next thing I'm going to do is, back up in main. I'm going to do a scan double. I'm calling scan double down here. I printed this out just so to help me debug and see what's going on with the flow of execution. I'm asking the person, I have to create my scanner first before I take some input. I'm asking the person to enter a number. And after they enter the number, I'm verifying that it's actually a double because I want it to be a double. If it's a string, I'm going to like in this case, I don't test it. I'm doing that next. But the first one doesn't really, it checks if it's a double, but it doesn't really do anything to it. It gets the next double. Okay? So it'll take the logarithm of the number that I give. In the third case, this is where I'm actually checking to see if it is a double or not. The thing that I'm actually inputting. If it's bad, if I'm inputting a string, you obviously can't take the logarithm of a string, so that would be an error. So I do the scan double, which does no error checking, other than to see if it's a positive number. Then I do scan double 2, which not only checks to see if it's a positive number, because get the logarithm function here, print logarithm checks that. So not only would check to see if it's positive, before it even goes to that point, it would check to see if it's a valid number, if it's even a number instead of a string. So let's see what happens when we run this. Okay, so the first thing was, remember, it entered print logarithm. I had the log. I wanted to know what the log to the base e, that would give me 2.718. Remember I said that should be approximately 1 because e to the 1 is e. And there it is. It's approximately 1. Now I enter scan double, which wants a number. Let's just see what happens if I give it a bad number. Remember, you can't take the log of a negative number. There, it gives me the error message, and that came from when we had the system error println. Okay, that was our error message. We actually said in here, let's see where it is. See, error x must be positive. That's exactly our error message. Okay, the next thing is now we're trying to enter a number. Let's give it again. Let's give it e again. Yeah, just see what we should get approximately 1 again for our answer. Okay, and there you can see it did it correctly. But this third case, when it did scan double 2, this one, not only does it verify the input's a number, when it calls print logarithm, it also verifies that it's a positive number, which it's required to be. So that does 2 types of validity checking of my input.